Thank you for coming to today's talk on maritime operational and safety systems cyber risk reduction, focusing on utilizing the consequence-driven cyber-informed engineering for maritime domain systems. I'm Marco Ayala. I'll be your presenter today. I'm going to jump into the discussion. This is a short talk, but the reality of systems today is that maritime transportation, maritime domain systems are targets. Here in August of 2021, Port of Houston had a threat actor that is believed to be a nation state. Thankfully, they had quick, timely response to actions. They were able to detect, and luckily it didn't impact operations. It could have, based off of what we understand, but thankfully the resources there were on point that day, and kudos to them. But the reality is that many of our ports, especially those that are part of the information sharing ISACs, know that we have constant bombardment of systems, from phishing to you name it. And so we have to be very cognizant of that, and we have to do our due diligence on systems. So some of the key things for the CCE, which is a consequence-driven cyber-informed engineering, is understanding what your systems are, the consequences of what could impact your operations, and really looking at the engineering side of what you have from process knowledge, but also how to protect these systems. Some of the key aspects that are different than a typical risk assessment that I've seen, and I've actually have seen on different standards-based assessments, is that you try to dial in and figure out what likelihood is going to be, and try to associate a number with that. Well, with the CCE, the assuming, taking an aggressor mindset, you really look at it from that the access has been achieved, the adversary has logical and physical access, including credentials, IP addresses, configurations, VSAT, maybe copies of the drilling system, vessel power management systems. And so the adversary has knowledge, the adversary is well sourced, but we take this as a Boolean of yes, they're in. And so even strong cyber hygiene may not withstand a targeted attack campaign with the intent on catastrophic damage. So I think this is a little bit different with the CCE standpoint, is coming in and saying, what do we have in place to protect us from this adversary that already may have a stronghold into our system? So safeguarding maritime critical infrastructure systems, the consequence-driven cyber-informed engineering methodology really has a deep dive into your maritime systems. It takes time, it takes resources, it takes trusted trained partners and facilitators, and must become part of a company's culture. So focusing on the impact of potentially negative events, ripple and domino effects, the CCE methodology provides a much clearer understanding of how, by technical means and pathways, and the why, the outcomes and intent, and how adversaries can affect critical functions and services using cyber-enabled sabotage. Because let's face the facts, folks. Impacts to the maritime domain by purposeful cyber means is cyber sabotage. So the CCE methodology is a 4-step process for safeguarding critical infrastructure operations. In phase 1, the consequence prioritization, the key piece here is that you identify functions that must not fail and associated events that would trigger failure of those critical functions. So proceed with the events that possess the greatest potential impact. And so a team will work together to develop the boundaries, the thresholds for the events and cyber events that could be catastrophic to your organization. So this is the phase where we typically prioritize and determine which can be deemed HCEs, or high consequence events. And so we look at area impacted. We look at duration and downtime. We look at attack breadth, which describes the extent to which a targeted technology or system is deployed, resulting in adverse operational effects. System integrity, confidence, describes whether restoration or recovery efforts can restore system integrity with confidence following an event. And some examples of that are, operating systems not being able to come back up, or they're questionable. The other part of it too is a key piece between attack breadth and system integrity is safety. Understanding the impacts on safety, including injuries, even environment. to your business impact. So loss of life, injuries, attack breath, all that are key pieces. And then looking at the public sector, which we're dealing with maritime here, but the cost for recovery, including restoration. What does that cost look like? What does an impact look like to you? What does 1 day downtime and throughput look like to your organization? What does 7 days look like to you? What does 1 month look like into your outage and downtime in a worst case scenario? So we want to really look at developing and utilizing scoring criteria and thresholds in this phase. And typically preferred is having a no, it's not affecting us, a low, where it affects us from a low standpoint, to a medium to a high critical impact. And so it's important within phase one to really sit down with the team, the maritime team, and be able to look through this. Phase two is really about the systems of systems. And it's important that we identify, we collect, and organize all information regarding the critical systems involved from the first phase that we deem from the events. Another key category here that you should be making sure that you have is data protection, having a data protection plan. Phase two, it's imperative that the protection of this data is secure, because the information gathered in maritime must be controlled, and you don't want the blueprints to get away. Other pieces here is that the team, the actual CCE team, maps out the systems and processes related to the high consequence events, which you identified earlier, and then investigates the dependencies in unverified trust, which would enable them. And so unverified trust, think of it as the blind reliance placed on the people, the process, and the technologies. Vendor access, system updates, patches, knowledge transfer, publishing RFIs, RFQs with a lot of information. A lot of these things can help threat actors build a comprehensive idea of your plot plan. So phase two is that system of systems analysis. So things like what systems are and equipment are involved in this high consequence event. Are we talking propulsion? Are we talking cranes? Are we talking motor control centers, power? All these things we have to look at. Drilling systems, blowout preventers, whatever it may be in your maritime domain. And then what documentation is needed to describe interconnected systems and those interdependencies? And what relationships with other entities are involved, such as third parties, clients, so forth. Phase three then goes into consequence-based targeting. So as I said earlier, in the Port of Houston, where we know that these attempts on our ports and our maritime systems have been going on for years now, the consequence-based targeting really develops scenarios to determine the paths, the pathways in, the targets, the access, and information an adversary or cyber actor would need to achieve the events. So the CCE team really refines and develops the targeting requirements an adversary would need to fully understand the attack in detail and to consequently carry it out. So consequence-based targeting is what you need, where can I get it, who has access. And in the world we live in today, we can get a lot of information online, from vendor manuals to typical reference architectures, to even protocols, even to information within folks at companies where they may have, hey, we use this system and I'm a SME and this manufacturer. Well, it helps the threat actor understand. So really having that information out there can be very damning or damaging to your bottom line, your mission. So we have to start from an engineering standpoint in everything that we do, understand that we have to start reducing as much information as we're putting out there on our critical operations and systems. So phase three, again, is really looking at targeting. How can the infection be introduced, and what does the spread look like, and what is the effect? And so that targeting is usually done by key folks that have deep knowledge into not just the systems, but also the engineering. So it does take a team from your side, but also trusted consequence-driven cyber-informed trainers and instructors that can help with the assessment. And And then phase 4 is really the kill chain mitigation. So phase 4 is develop mitigations and protections to prevent and definitely to limit, respond to, and to recover from an adversary carrying out the scenarios developed earlier in your earlier phase. So in this final phase, the priority really for maritime systems is to take the possibility of the physical effects through cyber means out of the equation using engineering and or process changes or technology reviews to understand how exposed are we. So a key piece here is if you cannot remove the possibility or it is impossible, then use the detailed targeting from phase 3 of the CCE process to detect cyber actor activity and try to implement other types of mitigations, whether those are mechanical fail-safes or mechanical isolations, or what I've been saying for many years now, a true demarcation that the site and operations can manage and disconnect and operate from. And the other pieces of that is making sure that you have some form of ingress, egress, capture of your system. So really looking at the kill chain mitigation strategy there within CCE. And so I'm at the end of my talk here, but some key pieces to think about here is the CCE provides critical infrastructure owners, operators, so ports, terminals, ships, offshore vessels, drill ships, offshore production platforms, and the manufacturers, whether you're an OEM for a drill chair system or for a BOP or for crane control. It gives you a much more focused bottom line approach to the systems upon systems that you have. So key things here is determine most critical functions that you have, identify the methods an adversary could use to compromise the critical functions, evaluate your complex systems, and apply proven engineering, protection, and mitigation strategies to isolate and protect our industry and our nation's most critical assets. And I think that's a very important piece. And so really want to say, kudos to the INL team, the Idaho National Labs team, for working diligently on this methodology, because I think it makes sense, especially trying to rule out as far as the attack attempts, but trying to linearize a likelihood scale. What I like about CCE is that it already gives you that Boolean of true within that scale. So I'm going to go ahead and open it up for questions. Contact information for me is listed here. So thank you for your time today and look forward to your questions.